how long have we known about the potential for human-induced climate change, and why is it taking so long to do something? My sister pointed out to me that it feels like the first time that anyone really got worried about climate change is in Al Gore's 2006 The Inconvenient Truth. I asked some older relatives and they agreed, and interestingly pointed out that concerns about the ozone hole, a related but different issue, had a large media presence since its discovery in the 80s. What is so interesting about this to me is that the greenhouse effect has been known since the 1800s, yet here we are in 2020 and the biggest environmental crisis facing us is not an ozone hole, which we've only known about for a couple decades, but carbon emissions that have been plaguing us since the Industrial Revolution. If you look up the phrase climate change in action, you will find a lot of articles, papers, and videos that discuss the psychology of it. Professor of Behavioral Neuroscience at University College London, Kate Jeffrey, makes some good points in her lecture on the topic, that the human mind has difficulty comprehending orders of magnitude. On the topic of a 1.5 degrees Celsius average warming, she says, "Logically, I think we all believe them, but even I, thinking as much as I have been about climate change recently, I find it really hard to get worried about 1.5 degrees Celsius. I just don't know what that means. I don't understand it in a visceral way. I understand it intellectually." Similarly, in his PBS Science segment, How Your Brain Stops You from Taking Climate Change Seriously, Stikon Ackman points out that the human brain is evolutionarily not well equipped to think about long-term problems. He says, "Part of the reason it takes us so long to act is because the human brain has spent nearly 200,000 years focused on the present. Find food, make shelter, mate. We only began to contemplate time and by extension the future within the last few hundred years." He continues, "Our minds, regardless of one's political or socioeconomic status, are constantly looking for ways to tell ourselves that business as usual is okay. News of disappearing glaciers fail to inspire serious change because of this cognitive shield." This reasoning explains a part of the difference in speed of political action between climate change and the ozone hole. The ozone hole posed a much more imminent threat and thus was able to intercept our business as usual mindset. To clarify why the ozone hole was perceived as a more imminent threat, I will briefly review this history. The ozone hole refers to the observed thinning of stratospheric ozone, first by a group of atmospheric chemists at an Antarctic station in the 70s and 80s. While in the region of the atmosphere where we live, called the troposphere, ozone is a pollutant. In the stratosphere, it plays a critical role in shielding us and other life from harmful high-energy UV light. Before this UV light can reach us in the troposphere, it is absorbed by ozone in the stratosphere. When ozone absorbs this high-energy light, it actually breaks apart into molecular oxygen and oxygen radical. The ozone layer exists because of a careful balance between depletion of ozone and reformation of ozone. Human emission of pollutants like chlorofluorocarbons, or CFCs, are responsible for catalyzing ozone depletion, throwing off this balance. There are many molecules that are capable of catalyzing ozone loss, but what was particularly threatening about CFCs were their mass use in aerosol sprays and refrigerants and long atmospheric lifetimes. This means that they are able to travel up into the stratosphere and persist, catalyzing ozone loss for a very long time. In fact, the EPA estimates that one chlorine atom can destroy over 100,000 ozone molecules before it is removed from the stratosphere. If you look at a timeline, global responses to stop stratospheric ozone loss were incredibly fast. The historic Nature paper, first detailing the observation, was released in 1985, and a NASA ozone mapping spectrometer verified this in 1986. Quickly in the following years, famous chemists like Susan Solomon, Paul Crutzen, Luisa and Mario Molina, to name a few, unraveled the key mechanisms responsible for observed ozone depletion. By September of 1987, the famous international treaty, the Montreal Protocol, was first signed by the United Nations and entered into force by January 1989. The treaty set guidelines for an expedient phase-out of CFCs. Let's now compare this to our history on climate warming products produced largely from combustion of hydrocarbons. I will start by pointing out that these combustion products not only cause climate warming, but they also harm human health, and this has been known for a long time, and I mean a very long time. The Smithsonian has a great piece on the history of air pollution, and in it they note that Roman courts considered civil claims over smoke pollution 2,000 years ago. Coal usage seems pretty universal across civilizations, with archaeological evidence of household usage in ancient China and the Aztecs in the Americas. Later, large cities like London faced air pollution problems even before the development of factories. Complaints about smoke and pollution increased in the 1600s, resulting in King James I passing legislation to restrict coal burning, which ultimately proved ineffective. During industrialization, the expansion of urban factories, which rely on coal and fossil fuel burning, formed hazes and smogs, which burned the lungs and eyes of city dwellers and impaired visibility. In the 1800s, scientists began to understand how gases in the atmosphere impacted, in addition to human health, Earth's climate. As early as 1824, the term greenhouse gas was coined by physicist and mathematician Joseph Fourier. In calculations involving their size and distance from the sun, he determined something must be insulating Earth, as otherwise it would be much colder. In 1861, John Tyndall showed that water vapor and some other gases display this greenhouse effect, concluding, "Aqueous vapor is a blanket more necessary to vegetable life in England than clothing is to man." Then, still over 100 years ago, in 1896, Svante Arrhenius published his paper on the influence of carbonic acid in the air upon the temperature of the ground. Yes, this is the same Arrhenius as in Arrhenius acid, the famous 1903 Nobel Prize winner. In addition to his famous work on charged ions in liquids, he was one of the first chemists to develop a model which predicted impact of increasing CO2 emissions. In further publications and orations in the early 1900s, he attempted to warn the scientific community about potential warming by a couple of degrees within the upcoming centuries. And considering he didn't know the rate at which emissions would grow, he did a pretty good job at predicting this urgency. Unfortunately, despite his renowned position in the sciences, Arrhenius' work on global warming was generally met with skepticism. His work was revived later by engineer and inventor Guy Callendar in a 1938 publication which compiled temperature and CO2 concentrations, indicating temperatures had increased over the last century, correlating with rise in CO2. Still, this data and related work by other climatologists was largely ignored until 1958, when Charles Keeling developed a measurement facility at Mauna Loa in Hawaii, which indisputably displayed rise in CO2 concentration. The famous plots that you often see displaying temperature versus CO2 increase is named the Keeling curve. We should pause here for a moment and review. So the ozone hole was noticed in the late 1970s, and the famous Nature paper on the Antarctic data was published in 1985. This sparked a fury of scientific work on the topic, and only 2 years later, the United Nations convened and agreed to phase out emissions of ozone-depleting chemicals with the enforceable Montreal Protocol. Compare this to climate change, where a renowned Nobel Prize-winning chemist, Svante Arrhenius, first warned us about our CO2 emissions in 1896. He and other concerned colleagues were basically continuously ignored until the 1960s. But even then, political action lagged behind the scientific evidence. The 1995 convening of the International Panel on Climate Change is considered the first time the United Nations made a definitive statement that humans are responsible for climate change. Despite this scientifically indisputable threat, we still have no international enforceable treaty to reduce carbon emissions. I think that human psychology, as mentioned earlier, can in part explain the difference in this response. The ozone hole was already present and thus seemed a much more urgent issue. Meanwhile, while the temperature had already increased from its pre-industrial values at the time of these early works, the impacts were not visceral yet, as Kate Jeffrey put it. I would say now in 2020, the effects of climate change are becoming a lot more visceral. We are seeing increases in droughts and wildfires, and some places are becoming so unlivably hot that people are having to relocate, becoming climate refugees. Something that I don't like about this perspective, though, is how it intends to place a sort of universal blame, that everyone was equally complacent with a business-as-usual mindset and thus are all equally responsible for emissions. That because I didn't buy food locally and because I wasted electricity or I didn't bike to work today, I am responsible for climate change. Don't get me wrong, I think we should all attempt to do things like this, source food locally and carpool to work to reduce our individual emissions. But the fact is that the average working class individuals are not really the ones responsible for this situation. When I was an undergrad, a professor I really respect caught myself and some other chemists discussing whether or not it was ethical to work at a company like Chevron. And she said that I didn't really have a place talking about such a thing because I drive a car that uses gas, don't I? The fact is that most of us do not drive cars for our love of fossil fuels and our support of pollution, but instead because we must commute to work, and for many of us, this is our only transportation option. I do not monetarily benefit from the preferential use of polluting fuels, and the odds are that most of you watching don't either. At the time that CFCs were found to be destroying our ozone layer, only a handful of companies were producing and thus making money off of CFC production, specifically Frigidaire, General Motors, and DuPont. But the automobile was invented in 1886, and since oil has led with coal consumption as the two largest sources of greenhouse gas emissions. There are dozens of huge, powerful corporations making billions off of forced consumption of their fossil fuel products. There are two main strategies that the fossil fuel industry has employed to prevent climate action that would result in the replacement of their products with renewable energy sources. These strategies are 1. Spreading misinformation. This includes covering up real science even when it has been performed by their own chemists. And 2, using economic and political power to prevent research and development of alternative energy. You may remember the ExxonMobil controversy, that basically in the 70s, their chemists had determined the consequences of continual fossil fuel burning, but instead, ExxonMobil covered it up and created a multi-million-dollar misinformation campaign. Because the topic of how this industry gained and misused its political power is so large, I'm just going to make a separate video on this topic. But to conclude this video, I would like you to take away some key points. 1, we have known about the consequences of combusting hydrocarbons for a very long time. Some scientists like Arrhenius and his colleagues have known for over 100 years. 2, human psychology is partially to blame for why it has taken so long to make real action. It is hard for humans to feel concern for problems that are not urgent. 3, despite what it may seem like, our international community is capable of quick action to prevent emission of harmful species. We saw this during the ozone hole crisis. But 4, the largest difference between the threat of the ozone hole and climate change is that many multi-billion-dollar companies with great political power are monetarily benefiting from forced consumption of their products. This is pretty much the end of the video, and I hate to end on such a negative note, but I hope this makes you all as angry as it makes me. Companies that purposely prevented climate change action need to be held financially accountable for the damage that they've done to our climate. And for this reason, I invite you to comment ways in which we can remove economic and political power from them on this video. See you next time! Now, how do I do it, Heather? So yeah, bye!
That was not...
Okay, stop doing that for a minute. Heather!